The snowfall and hail are almost a similar process, but a little bit smaller modification in it. Smaller modification. I will explain the process. Just listen here. Okay. This is a high altitude mountain. Okay, maybe something like we can keep a Rotang Pass or maybe a Nathula Pass. You know what is Rotang Pass? Rotang Pass. Period. Nathula Pass. Period. Yeah, that's good. You don't know, no? I can teach. Then I will see. Class Rotang Pass. I have a comparison. It is in Manali. Exactly. It is Manali. Okay, just Manali is on the foothill. Rotang Pass in the top. Around 3,800 meters of altitude. Nathula Pass is around 4,500 meters of altitude. Okay. These are tourist places. Not tourist places now. We can go and see and come back. That's very interesting. So now I am taking this is okay. Take this Manali. Okay, and there is an air. Okay, the top of the mountain. There is an air parcel with a temperature of 3 degrees Celsius. Temperature of 3 degrees Celsius. As it is on the mountain top and a lower temperature, it will have a very low amount of water molecules. Have less water content. So keep it. This is here 2 gram. You have only 2 gram. So 2 gram of water vapor. So 3 degrees Celsius, 2 gram of water vapor in it. Now this air mass rises very slowly. Rises very slowly. Where is that? Slow. So that's like very slow rising of an air mass. When air mass rises very slowly, when it reaches sub 0 degrees Celsius, how long it has to travel? Rapid long, slower the more. Less than half kilometer, because only 3 degrees Celsius. Less than half a kilometer. Once it reaches sub 0 degrees Celsius. After reaching sub 0 degrees Celsius, it may get saturation. It may get saturation because temperature reduced, so size also will get reduced. Then saturation, the capacity goes less than 2 grams. Then water vapor started to release out. Just imagine, it's a very slow movement of an air. Each and every movement, it has to release the water vapor. So when even it moves 1 feet, that excess water will be comes out. Moves another feet, excess water will come out. The excess water will be such a way that it may be 0.01 gram. How much it will be? 0.01 gram or maybe less than that also. Because already it's having only 2 gram of water vapor and it's very slowly it's moving. So it's getting out whenever it gets saturates. So 0.01 or maybe 0.005 has a very lower amount of water vapor released out at 0 degrees Celsius, less than 0 degrees Celsius, sub 0 degrees Celsius. What happened to that 0.05 gram of water vapor comes out into the sub 0 degrees Celsius? It will become cloud at sub 0 degrees Celsius. It will become ice. So 0.05, it may be 0.1 gram of water vapor which comes out. It cannot form a bigger ice crystal. It forms a thin ice flakes, something like a cotton fiber. Very thin, just when come out the water vapor, it forms a thin flakes of a ice. It just is a float on the air and is fall on the ground. It's called as snow. Right? That's called snow. That also solid form. That also formed at sub 0 degrees Celsius. That also induced by rising of air. Something like hail. Hail also we had a rising of air. This also formed due to sub 0 degrees Celsius. So both are similar, but process completely different rate of process. Clear? If we compare with snow and hail, okay, you can say snow and hail, the process, if we compare it, number one, so both have a, snow will have a low amount of moisture content, but in hail, high moisture content. And in snow, slow rising of air, but in hail, rapid rising of air. But only one similarity, saturation at sub-0 degrees Celsius.